Hi everybody. Today I would like to uh, repeat the lecture about structure of the computer. Computer structure, folks, is very similar for big computers, for small computers like a cell phone, or even for huge computers like a mainframe. All of these computers created with microprocessor inside. Not about microprocessor, because microprocessor is a microchip developed in latest 20 years. But before, computer were much bigger, and microprocessor was just processor. So what is processor or microprocessor for the contemporary computer that we're talking about now? Microprocessor. Microprocessor is microchip that installed on the specific circuit, and it has internal clock, which ticking and give the written process to processor like this. But the speed of ticking is much higher. So useful reading for the microprocessor is about 3 billion tick tock per second. So it's pretty fast. Then microprocessor doesn't know what to do. It is capable to produce things such as logical operations and arithmetical, textual work and calculations. But without program, it actually helpless. So program. When we put the list of what to do today, we use paper. Microprocessor doesn't have a paper, so the only thing for microprocessor where microprocessor can record its stuff is memory. Memory is electronic device. Memory. Electronic device looks like a table. So when you go for memory, you will see bunch of cells. Some cells could be 32-bit, but for more expensive computers, they are 64-bit. Definitely 64-bit. Memory must be compatible with 64-bit processor. Memory is connected to microprocessor with asynchronous manner, which means that microprocessor can do its own operation, and whenever it need to ask memory to send or to record information from it, memory could be not ready and doing this its job separately. So to make them work together, we need some kind of device that function is like a secretary. So that device I will put here, the long middleman like long rectangle, and that device called bus. Bus it's called because there's information delivery tool. How it works: microprocessor requests bus to work with him. Bus responds that bus is ready. Then microprocessor asks bus, can you ask memory cell number 5 to be ready to give me information? Then bus asks memory, definitely in electronic form, can you prepare cell number 5 for giving information to MP? And memory said yes, and then give information, bus send information to microprocessor. So this shuttle-like exchange with information is reliable and can be synchronously sent between bus and microprocessor, between bus and memory. Okay, memory cells, every cell is enumerated. It has its own number. For example, this cell is number 4. But number 4, folks, that will be binary number 4. So that will be 100. How many cells in a memory? Contemporary memory, folks, is about 16 gigabyte for the computer, or maybe more, 32 gigabyte, or even 64. Memory is a placeholder for binary data. So binary data is a raw information converted to the binary form. But memory is also the placeholder for the program. Program, folks, is a set of instructions for microprocessor. In a certain time, I will tell you how program can control microprocessor. Program is also written in binary form or converted into binary form. And pretty simple question, who and what is created of the program? And I can tell you folks that this is a profession named programmer, people who can use different programming languages to write the program that will control microprocessor. Okay, memory can be used by microprocessor randomly. So any cell could be called for reading, meaning bring information from memory to microprocessor. So that is read, send information from memory to microprocessor, and write when microprocessor put information for memorization into memory. So the addresses for this could be chosen randomly, meaning this named random access memory. So access to any cell number could be done randomly according needs of microprocessor or program dictate. Folks, memory has a feature. When the power is zero, memory will be zeroed. That vulnerability is make computer necessary to have the storage device. Storage device, folks, I'll put it here. Storage device for information. It could be HDD, hard disk drive, or SSD, which is big flash drive. Memory is speedy, so the cycle read-write could be 9 nanosecond. 9 nanosecond. That is 9 multiplied by 10 in the power of 9 second. That is very small fraction of second. So it produces 9 billion cycles read-write in second. Storage device also connected to the bus bidirectionally, so storage can send information from which is stored inside or record information. Storage is much slower, so its cycle is about 8 milliseconds. 8 milliseconds. This structure must have input device, which is keyboard and mouse. This is strictly input device, keyboard and mouse. Then, folks, we need to display something, so that will be monitor. And monitor is just TV, so to be compatible with binary computer information for displaying, we need to have adapter, which is Visual Graphic Adapter, VGA, Video Graphic Adapter. It will be converting what computer calculated concerning video and send video information to the monitor. Folks, to place certain information into computer could be supplied with DVD drive or CD drive. CD to play music or to place programs, and even to record CD. So that is CD, DVD, RW, rewritable drive. Usually these drives in expensive computers or in desktop. We need to have ports. Port is USB collection of ports for external devices. That is USB. Union Serial Bus or United or Unified Serial Bus. So many devices could be connected to this USB. This computer already can function, but we forgot to put a couple of things. That is network adapter. Network adapter definitely bidirectional because it convert the language from the cable to the language of the binary system of the computer. Usually network adapter could be connected to Wi-Fi model, Wi-Fi with antenna, or that could be connected to internet provider. Internet provider, let's say Optimum Online or Fios, internet service provider. It's bidirectional too because you can send and receive your email. Alright, folks, so that is network. I forgot one more thing that will be, I'll put it here, audio system, which connected to the speaker and microphone. Speaker and microphone. The only one thing we need to do. This computer is actually done, but it cannot start. Why it cannot start, folks? Because when you turn on the computer, the memory will be empty, and microprocessor have no idea how to load any information from CD or from storage device, because microprocessor only can do this under program, under the system of instructions that coming from the programming. But in this case, microprocessor will be helpless because it's empty and memory is empty. So for this case, people who create this computer, they will put a certain chip, the chip named BIOS. The information from the BIOS will go to the bus, and BIOS is initial start program. Now it is possible to start this computer. How to start it? When we turn the power on, BIOS will wake up the first, and then it send signal to the bus, meaning bus, I'm gonna start, and bus will take initial program and will place it into the programming area into memory. Then bus will inform microprocessor that startup program is ready for microprocessor, and microprocessor will take information from the programming and start doing the first instructions. These instructions, folks, named POST in many computers, power on self-test. This is self-test request all the devices that connected to the computer to send information that confirmed their presence, their attendance to microprocessor. After that, when the self-test is finished, microprocessor gives signal to storage device to load after this load operating system. Folks, operating system is a residential program that actually stand for interface between user and computer. And actually this is supervision function that gives computer opportunity to function. It control every device. It control the modes that display use and settings for any and every device. So this is complicated program. We will use Windows in our case, Windows, but our operating system could be created by different companies, not only for Microsoft. And for example, Macintosh, Apple OS, or Linux, and other operating systems. We'll speak about operating systems later, but now I would like to speak about microprocessor and how it reacts for the command systems. Operating system, as I told you, taking all the functions of the computer for organization, protection, authentication, connection to the internet, and many others. But so far, let me change the piece of paper, and I will explain you how to programmable device is working. Okay, as I told you before, computer can accommodate alphanumeric data, visual data, and mathematical information. So this mathematical information allows computer to calculate. So let's see how the simple program works for calculation. A simple formula. Simple formula like this: y is equal x square plus b minus c divided by k. I can put here all on the paper, but in the computer where there's no paper, we need to use only memory. So we need to distribute memory to create a program for all of this data, to request the real value of this data from the user when the program is running for inputting all the data for these cells. So let's say we distribute a certain cells. I can use memory randomly, so let me go for cell number 5. I'll put it in a bracket, meaning this is cell address, and that will be reserved for X. Cell number 6 will be reservation for B. Cell number 7 will be reserved for C. Cell number 8 will be reserved for K. And cell number 9 I will reserve for Y. And also I need to reserve 5 byte, meaning that will be cell number 10 for the word type, and cell number 11 for the word value. This apostrophe means this is alphanumeric information. If I need more cells, folks, I will reserve more cells for that. But in binary code, that will be cell number 0101, that is 0110. You can check the address. This is 0111, next 1000, 1001, that is 1010, and that is 1011. Binary enumeration for the cells. Now, folks, I will pretend that computer understand mnemonic number of operations, type of operations, but in reality that must be binary code of operation. So I will go for word start the program, and that will be first input and output. The first command will be display. Display meaning show on the monitor. Cell number 10, content of cell number 10, that is type, that is cell number 11. This type value. But to know which variable we need to type, I need 5 more cells. 1, 2, 3, 4. 4 cells. 12, that will be X. 13 will be B. 14 will be C, and 15 will be K. Apostrophe means this is just letters. And also I'll put here display 12. So what user will see on a screen? Type value X. Then user will type it and processor write to the value of X, cell 5. Again, we will display words type value X, and then user typing, and then we will write to the cell number 5. Then I will do all of these 3 operations again. Display, I will put here 10, 11, 13, just to save space. And then write, that is B6. Then again, display 10, 11, 14, write, this is C to 7, cell number 7. And the last one is display 10, 11, 15, write, that is K, cell number 8. So all data is here. Next, read 5. Then this symbol is multiply by 5. Multiply by 5, meaning we create X squared. It still live inside of microprocessor. Plus, what is B? B is cell 6. Plus 6, content cell number 6, minus cell number 7, minus cell number 7, divide by cell number 8, meaning content what is cell number 8, and write to cell number 9. Write to cell number 9. So to see what is Y, we need then to go to display Y, and then stop. So folks, how this program is functioning. This from the beginning to the operation, let's enumerate them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, this is 17 and 18. From operation 1 to operation 10, it's just input part. We collect the value of our variables. And then this is just calculation. Read cell number 5, read X. Multiply by cell number 5. The cell X is already inside of microprocessor. When it multiplies by itself, that will be X squared. So just in the memory, just X. Here in the memory of microprocessor, X squared. That will be calculated X squared plus B, and so on. Eventually, we calculated Y and stop processor. So that is sample of programming. Programmer, before it create program, must draw the algorithm. Algorithm is the graphical representation of the logical system which will be programmed. And algorithm, we will learn how to make it in the next session. Thank you.